Well, hello, good morning. It's me and my cat here in my shop getting ready to start work over here. Shadow doesn't come up on my bench very much anymore. So I flipped on the camera rather quick to catch her here. Now, let me get this out of here. I've been doing vast amounts of tube testing in the evenings here. You can see some of the... Yeah, that's right, I made a big space for you, cat. You can see some of the tubes I've been testing here. Let me put these away. Okay, now I think we're just about ready to get going. So the situation with this radio is it appears as if the volume is right out of control on it. It certainly appears that way. And I suspect the reason for this is I've made a mistake in doing the capacitor work in the back. So, and I just realized too, I've taken one tube out to test it and it's gone away in a box of tubes. I'll have to find that. So I think the first thing I want to do is just verify some of the connections underneath here. Look what she's found. Wouldn't you know it? She would find that in my shop. Looks like the birds she stares at all day out the window in our house. Okay. It's going to be another cool, cloudy day here, I'm afraid. So let's look underneath. Shadow, you can help out with this, okay? There we go. Shadow, you want to take a look inside here and tell me what you think? What do you think is really the problem here? So off the volume control, how do you like that? There's this capacitor and this capacitor. Now the way I did this, I made sure I couldn't make an error. That's why I'm pretty sure I have made an error. So I'm going to verify these two capacitors before we go any further. What do you say? Shadow, you going to jump down? Go on. Go on. Jump down. Okay, I'll get the schematic out here and study it up. Okay, so I've checked as best I can. I don't think there's any wiring errors in here. It doesn't mean there isn't, it just means I can't spot it. At this point, everything seems really quite correct. So what I'm going to try to do anyway, is use my, use my signal tracer here to listen to the signal as it approaches the volume control. Listen to it on coming out of the detector and going into the volume control, and see if it's a noisy mess there. The problem with doing this is basically the speaker is going to be screaming loud, and I'm going to be trying to listen to my tracer at the same time this thing is screaming. So I'll try and get that set up. Let's see, I can leave the cameras running, I think. So volume is minimal. Actually, it's off right now. Set here, okay. Well, I'm going to want to make this connection. I'm going to want to put the ground wire from my tracer in here, but not on the chassis. I don't think I'm going to go on the chassis. What I'm going to do, this is a great big clip here. I don't want this strained in the radio for fear of generating a short. So I'm going to extend this, the clip lead. Okay, I'm going to put this on the B- point. You can look at the incoming power switch. So this will be the spot. This will do it right here. So that's a B- connection point there. And we should be able to listen to what's coming out. Let's see. We're set over here on audio and a little more attenuation. Okay, we're ready to go. So it's going to be hard to hear this. over the speaker. For me, it's stereo here, of course. I can hear that it's coming from over here. But on the video, it may be very hard for you to figure out what you're hearing. And it's bound to be loud, so I'm probably going to back down the microphone volumes while I'm doing this. Okay, I think we're ready here. So. My dim bulbs didn't come. Oh, that's because I got the tube out still. Duh. Yeah. Okay. I'll go find the tube and get this going. Okay, so this is the best 6SA7 I tested. There we go. That should work a little better. Of course, with one tube out, these tube heaters are in series, none of them heated, and that's why my dim bulb didn't come to life. Okay, are we all set this time? Yes, I think so. And the last comment, I'm powering this from an isolation transformer. That's why I'm fairly free to connect other equipment into the radio. So I won't go into any more detail about that, but you see me doing things, you may not realize what has gone on before, or what is happening in the background, or what you take for granted in the shop, and all that kind of stuff. So if you're trying to imitate this stuff in your own home, you take your own safety. Your safety is your responsibility. So, okay. And my safety is my responsibility. Now, so we're going to want to touch here. And so this is the incoming signal, or what's coming out of the radio circuitry heading for the audio circuitry through the volume control. So we should hear audio here. It should sound the way we want it to sound coming out of the speaker. But if it sounds the very same as the speaker, then we know it's really not an issue in the volume control or beyond. It's something ahead of it. So I don't know what to expect. Let's just make sure our levels over here are good. I think that's okay. There we go. I hope this gets really loud. Oh yeah, volume. So I got my hand on the microphone volume control here. That's another thing, you can't really tell what volume is being moved up and down necessarily. So pretty quiet so far. Here it comes. Okay, great. Okay, I managed to open circuit the volume control there. So not much is making it into the audio part, so we can hear more on here of what is getting to the volume control. And this is what's getting there. What happened? Okay, we'll go back a step. It's incredibly quiet. Something not right here. Okay, so we can hear stuff coming out of the speaker. That's got to be on the slider. What's happening here? It's all pretty mysterious. Okay, let's go back another step. We'll go back to here. It's just zero. How can it be zero? Maybe this should be clicking and popping and jumping up and down. What's going on over here? Audio. Okay, I'm totally flummoxed. This has even gotten weirder. So have I made a mistake with the ground here? I can see that when I put this here, my ground connection in that is right across the volume control. Maybe I just don't have the volume up high enough on the tracer. Let me get it on here. There it is. Just chicken to turn the volume up on my... It doesn't sound screamingly loud. I can't really tell with this though. Give myself a shock here from there. Careful. Okay, so that's what's coming out of the radio. See how quiet it is there? So, this is a little weird too. So if this is so quiet, why is the radio so loud? If I tune between stations, like I am now, because the amplifier is running wide open in this radio, the audio amplifier. Anything gets to it, it blasts out of the speaker. Okay, so if that's the case, well, of course I've got the volume control open circuited right now, I believe. Okay, so I'll tune to a quiet spot here as best I can. Let me turn up the signal tracer further. Now it sounds like the radio, eh? Oh, for crying out loud. Okay. Because what I forgot is I'm hardly tuning this radio when I turn this knob. The pointer's hardly moving. Everything's sliding, so it's hardly being tuned like this. So we'll just pick a quiet spot where I can here. There. Okay, what do we hear out of the speaker? Same thing. Volume at minimum. Okay, output of the volume control slider. I mean, it's got to be the same, doesn't it? I can't hear it over the speaker anymore. Okay, well, it's that's a strange thing. It's still as if the volume control is just having no effect. Why would that be? Defective volume control. I don't know how a volume control can be that defective that way. Well, I don't know. I'm gonna spray some cleaner. Oops, spray some cleaner into the volume control. It's a long shot. I just have no idea at this point. It's okay when you're doing this work to have no idea for a while. That's okay. You don't always know what's going on. Maybe you almost never know what's going on, just at the last minute. Oops. I can't imagine this would fix it. I've been surprised before. But this would blow me away if this actually fixes this radio. Okay, let's be blown away. Now, there was a lot of crackly stuff in this radio too. That's still there? I don't think that's there anymore. Minimum volume, and there it is, all there. So there's some kind of like voltage divider problem here. There's maybe a resistor that's in series with the volume control that's not doing its thing, like this one right here. The idea is you've got a voltage divider happening. The volume control itself is a voltage divider. I don't know. This is really kind of weird. So I'm going to stare at the schematic some more, because there's something really weird about this. Okay, let's poke around with the volume control itself here. So I've got my ohm meter connected to some clip leads. Goes right down to 0 on the 2 meg scale. This is supposed to be a half a meg ohm right across the volume control. Of course, I'm doing this with the volume control in the circuit. I think we can only read lower. Okay, so I get on the bottom of the volume control there. Yeah, if it looks like I just clipped onto the power terminal, I kind of did, because it's tied to the control. So here we see the, wow, 16, 17, 1.8 million, and it's supposed to be a half. That's way off. It's kind of jumping around there, isn't it? Okay, so the let me just pull the plug out of the outlet here just to be sure. Now we're just gonna fool with the control here. Ooh. Okay, so it's getting up towards the limit. 2 million. Oh my gosh, look at this. Let's fiddle with it. Now turning this shouldn't change this reading at all. Looks like it's heading for 1.5. It's moving around. Well, okay, let me try flexing the flexing it a little bit here. I don't know what that would prove anyway, but I can do this. So now it's coming in around 2 and going, what's it doing? It's jumping all over the place. Could just be my clip leads are crummy here. It's a very high resistance reading, so I shouldn't really worry too much about my connections here. Let's make sure this one's good. Something's jumping all over the place. I haven't got the impression there's something loose in all this. would expect this to just go rock solid at some point. That's pretty solid there. Oh! Okay, I'm not sure what to make. All kinds of readings here. So I'm going to put this on the slider. Okay, and we should see from 0. Oh my gosh, that's really not a 0 happening there. Okay, let's try this. Okay, so that's starting at 0, going up to 500,000. Right, that's exactly where it's supposed to go. So from one terminal to the slider, this is working beautifully. It's doing exactly what it should. Now if I connect to the other side, it should be doing exactly the opposite. But doing the same thing, but opposite. Look what you get. Oop, that's why you get that. There we are. Huge resistance. So I put a NOS capacitor in here, but a really high quality one that I tested quite thoroughly. So what? Let's test it again here. I think that's fine. 5-6 megohms across it. No doubt that's nothing to do with the capacitor. So what I'm getting here is a volume control that appears to have lost its ground. And that would turn it into, instead of a potentiometer, it would become nothing more than a series variable resistor, a 500,000 ohm variable resistor in series with, this guy here and the capacitor down here and who knows what else is in series with it. Probably that's the entire explanation for why this radio sounds like it's wide open. With the ground off the volume control, it essentially is. That's really a pain in the arse because you need another volume control that matches this one in many respects. Physically has a switch on the back. So this is a bit of a death knell for this radio, but I don't want it to go away and die now. I'll have to just rummage my parts boxes and see if I can come up with something that could go in here. Wow. I'm really pretty convinced the control here is the problem. It's not even worth releasing wires from it to further test it. I think I get exactly the same test result. So unfortunately, well, I should have maybe picked up on this earlier in the process here. But it is what it is. So everything comes eventually. I gotta go look for a volume control. Well, okay, my junk box parts aren't going to do it. Let's see what I got in here. So these are really Nordmendy radio parts that I got some time ago, and it's kind of a fat chance on any of these doing the trick here. Nothing close to the right size. A lot of these are stereo controls. I actually have two on the bottom. Nice looking resistors there. Shouldn't be in here. Okay, what's this? Now what are the chances I'm going to find a control that's going to fit in this radio and has a switch on the back? Why do you like that? But, fat chance it's a 500,000. 100K. Don't think there's any hope for that. Ooh, look at this guy. Oh, smokes. Wow. Hey, there's a switch on the back of that thing. Wow. Look at this guy. Wow. I don't know. That's quite the control. That's not going in here. Hey, I like looking for my parts boxes. Let's see what we got here. So I think I probably got a switchless volume control that will match pretty close. This is a 1 megohm, not a half megohm. Not in here, but in my other stuff. If I want to go without having an on-off switch, those are stereos. Stereo controls. Got quite a few, eh? Same thing here. Hey, if you need a Nordmendy part for your, hey, now these look more like what I'm after. Yeah, let's take a look at this. I usually put the oh, there's no ground tang. What's going on with these? Yeah, they're not sure. They're not a potentiometer. Here's one. This one's okay. Okay, maybe this will do it. AMF 5150. It doesn't give the. So this is a possibility, at least for the volume control, without the switch. Just a possibility. Oh, look at those great big monsters. Got quite a good Nordmendy stock here, right? Isn't that something? Now I'm looking it over. What's this? These are probably meant more for transistor radios. Oh, that's just a stereo volume control. Spring in it. Looks like it's a push, and then you engage the turning part back here, and then disengage it. Hey, that's fun. More tiny volume controls. Various. Wow. Look at that big honker there. Someday I will identify the stock properly and maybe offer it up on the internet or something. Well, that looks like a great big on-off switch there. Oh yeah. Hot diggity dog. Look at this baby. It's got a few too many terminals on it. Ruido, R-U-W-I-D-O. Never heard of that. Brand new. It's got 2 terminals here, 2 terminals here. Lots and lots of terminals. I don't see a value marked on it. I'd be really ashamed to put this. This is probably worth more than the whole radio over here. Very cool. I really got a huge bag of these guys. Oh, smokes. And well, it's just totally wrong for this radio. My only hope is these ones. That's all I got here so far. But what fun looking through my stock. I hope you don't mind me just kind of displaying this. I bought this at a ham radio flea market in cardboard boxes, piles of stuff, piles and piles. Stuff for not much money. There we go. Let's take a look at these volume controls that we're covered here now. Another option I have is to go steal one out of a radio. But this one we want to measure. That's only the two 2. Where's the 3? Here's the 3. Okay, so we're looking for 500,000 ohms between the outside terminals. Well, so 1.3, yeah, 1.3. I don't know, that's a long ways from 500,000. 1.3. What about some others in here? Probably all the very same. Exactly the same. I think these are all identical. Certainly look at. Well, I'm going to rummage some more because I'm not satisfied. I got a good deal here. Let's see if I pull out these resistors. Ooh, these aren't resistors. Yeah, they are. They're like wire wound. Oh, you know what these are? These are the fuse guys. 1500 ohms. So in a lot of European radios, they have a system of fusing. Now, these all look the same. 1500 ohms. And the idea is this wire how they did that exactly, I don't know, but anyway, the wire basically goes through, it loops around, and comes out, and right here is a solder spot, and this part of it you can see is spring loaded. You can see there's a bend in it. It's ready to spring up. You heat this thing up, this whole thing heats up, and this is the kind of fuse that is not intended to break a sudden rush, a sudden short circuit fault. This is the kind that's designed to detect where things are just getting a little too hot, where you just, you know, it's good for 1 amp and you got 1.1 amp flowing or something like that. And these things slowly will heat up and then they'll pop open. You can just solder it back. Can't imagine they're particularly precise. And I have found these popped open in radios. I found them like that. They do their jobs. Protect. European radios have a fair bit of fusing and protection in them. Sometimes they have a high voltage fuse and other stuff. European radios are a little, I don't want to say they're better, they just put more money into the radio basically. They're more expensive radios back in the day, I believe. What am I going to do here? I'm going to go rummage. I must go rummage more. Wish me luck on this. Okay, let's get this a look-see and find out if this has the control I'm looking for. This is a receiver someone gave me. The cabinet is long gone. The glass faceplate is long gone. And I've just had this in a box out in my garage. But what it has is it has a switch on it. So let's just check this guy out here. We can start off just by reading right across it. Let's got all this stuff hooked up to it. I don't think it's going to matter too much. It's a 200. Okay, it's a 200 with all that stuff on there. Where would we go here? Oh, 500,000. Hey, we have just found our baby here. I feel bad about doing this, you know, to anything. Taking out one part and sacrificing the rest of the radio, but this guy's got no cabinet. And let's try that reading again. Now I can cut off the wires. I'm looking for 500,000 here. Show me 500,000. Diggity dog. Whoop, whoop, whoop. There it is. 600,000. This guy's going to do it. He's long shafted. Got a flat spot. It's going to stick out. This will stick out, but I can cut. I can do something. I will do something. That's the guy there. Let's clean him off. Assuming the switch works. No reason to think it doesn't. Still got my coat on from being out in the garage here. Yes, you still need a coat, even to go in your garage. Okay, you know what? I'm going to get this out of here. You don't need to watch me struggle with that. I'm going to get it out, and then we're going to look at what happens when you stick it in the other radio. Great. I better move my cup of coffee. I'm breaking a big rule. Never put food or drink on your bench. Ever, ever. Ever, ever, ever. Okay, let me get that out. Okay, so this is not an instant repair by any means. The shaft here is way long. It's going to stick way out. More than an inch sticking out. So this knob, this will protrude right out the front of the radio. This will be sticking right out there. It'll look ridiculous is what it'll look like. So the normal thing is to cut these shafts the length you want. But the problem is it's shaped on the end here, and I need that shape to grab this knob. And if I decide, okay, I'll just get different knobs, get two knobs that'll go on a round shaft. This one's not round. This one is shaped. So how am I going to get two matching knobs? One goes on a round knob and the other one goes on a D-shaped knob, a shaft. So I'm going to think about that. But lunchtime has come, so that's what I'm going to do while I think about it. What can I do to make this radio look good and work? Okay, I did do a little more rummaging around. No, I can't find any other thing. So I've been thinking about this since the last few minutes. I think what I'm going to have to do, cut this to the right length, and then file off the edge so it looks like this again, and use this knob, and make this shaft appropriate for this knob. I think that's really the only way to go here. I mean, I'm lucky enough to have this. Good. Now I will go and have lunch, and I will be all ready for this new endeavor. It turns out it's only 11:30. It's not lunchtime yet. So next step along the way is to remove this one out of the radio, and then we'll test this one more thoroughly and see if we can't maybe even bring it back to life. Wouldn't that be great? That would be great, actually. I don't think there's much chance of that happening. Holy smokes, it's really tough to turn. So now I can spend some time thinking about what I want to eat for lunch. Let's see if we can get it with this. Now I'm going to try to cut the wires and leave them hanging just kind of as they are. And hopefully there's enough wire left to reattach to the new guy, which is basically identical, essentially. So it's going to be difficult. A lot of these leads are barely long enough to get there. Just cut them. I'm probably going to change this resistor. It's measuring slightly high anyway. Lots of connections here. And the incoming power wire. Okay, first thing I want to do is test this again. Dirty. Feels perfectly fine. I'm looking for half a meg between the ends here. Showing just open. So there's the truth. The truth is it's open circuited in there. We go in the center. This way we get nothing. Oh, might have been my fingers. Oh, I think it touched here. But if we go the other way, we actually get proper operation. So that even tells you which terminal it is. This terminal is no longer connected. And I've never tried taking I once when I was a kid I opened one of these up, and then it's not going back together after. Probably if you were really careful, and maybe as an adult I can get away with it, but a lot of these tangs that are bent over, you bend them up, you might get away with that. You bend them back, break right off. So they really aren't made to be repaired, although I know some people can do it. So what I need to do now is I need to cut the shaft off and then shape this part of it. That's almost all of it. This one's the same way. How far in does the knob actually come? Yikes. Potentially all that way? I guess so. I guess so. Kind of have to have the cabinet here to really, but if the knob isn't stopping because it's hitting something inside, then it's stopping because it's hitting the cabinet. That's no good. So this must be the stop. This must be the stop. Let's go all the way. Wow. But that, the grippy part's just maybe back to, it's like back to here. So a good portion of the shaft is just sitting inside there doing nothing. So I think let me put a feeler down there. Oh no. Oh no, this part here goes all the way back. So, you know, I pretty much have to duplicate this. I could shorten it up a little bit. It wouldn't really matter. I could shorten it up quite a bit, really. I think it wouldn't matter. So I'm just trying to assess the critical dimensions here because I'm cutting stuff and there's no cutting back. Now, if we look at these very carefully here, I'm comparing a few different things here. Okay, so we can washer this in here to change the amount of threads that stick through, but they match pretty close. This is a little longer than this. This one's going in slightly shorter. You can see the all these were exposed and the screw was way down here. So there's lots of thread here to go in. Once we're done, this is sitting in a little further, not by much. There's a stopper here and a stopper here. These are the rotating stoppers. How do they compare? Oh, very favorably. They're in the same position. Okay, let's dry fit this one in there. Because for sure I'll do the cutting. It would go in like this. Find out now if it really does fit. Yes, of course it does. And the little locky tang goes in beautifully. Nobody'll ever know. Look at all these wires go right back on there. Can you see? They all fit back on there. It's beautiful. And it turns on and off. Does it really? We better check that. Does it really turn on and off? That's one of those things where you put this whole, spend all this time putting this part in and then find out. Assumed it was working. So that's shorted and that's open. Perfect. We're golden. Okay, now to mark the cut point, maybe I'm going to do it with a little bit of tape. I need to tighten this right down on the radio. Well, what is stopping these things from shorting against the cabinet? This one's no different. Is it just dimensions? It's just managing to not short. Yeah, that's all it is. Very close. Okay. Now the task at hand. Remember, I can cut it a little shorter. I would not want to cut it any longer. The shorter I cut it, the less work it is in the end to shape it. Bring this down just a wee bit. Save myself a 1/4 inch there or something, 1/8 of an inch. Hacksaw it here. And then I don't know how I'm going to do this. I could Dremel this. I could just start filing and file away for a long time. Filing, lots of file, like pieces of metal file all over the place. Dremel's even worse, throwing metal everywhere. I should probably seal this thing up pretty good so none of it gets inside. Yet. And there's a tremendous vibration if you're hacksawing. It's really a lot of vibration. Maybe I should Dremel it off instead of hacksawing, because of just the amount of vibration in there. You just keep dremeling it down until it's like this. I think that's it. Now it's a question of doing it. Okay, here it is, ready to go. I'm out to do the damage. See what happens. Okay, let's see what we've got here. Yeah, I actually do use safety equipment when I do stuff like this. Out in my garage. Here we are, the cut shaft. How did we do? It's all taped up here. It's short. I've cut it short, quite a bit short. Oh, son of a gun, that's quite a bit short. Ah! Okay, so we're just going to have to, now it's just about exactly half, eh? Not quite. Not quite half is taken off. Doesn't matter where I do. Ooh, that's hot. That's really hot. Yeah. Okay, so how to make this? I don't know. I will go think about that. Okay, I think I've made this maybe a little bit too skinny. Let's see. Come on, baby. Well, it fits on there, but it's loose. Of course. And I'm sure I can solve that by just packing this with something. I think we're in business here. Whoops. Pull the cardboard there. There it is. Oh, I guess I left the original out in my garage. Yeah, I made that a little short. I think what I'm not accounting for is the amount of metal being removed by the Dremel. I think that's why I ended up a little short and ended up a little small. But we have got something here now. These have got bent back. Don't break them, champ. Don't break them. Let's leave it a little further on this one. Probably when I make the new connections, the old little bits of wire will fall off. Okay, don't break off. Don't break off. Hey, listen to me. Good. Okay, man. Now it's time for lunch. Excellent. I'm going to enjoy my lunch now. Okay. Now let's fit this guy in here. It's got the stopper tang there. Stop it from rotating. When you use big tools like this, you got to be careful when you go to rotate them that you're not bumping into something, because you can't necessarily feel it. So you're turning and you don't know it, but you've bumped into this, you know, or something like that. It's not readily apparent. You get a lot of power into the tool, do a lot of damage before you realize. That is solid. Okay. So I think I'll start by hooking up the the negative here. I gotta get that little wire out of there. I mean, I called it the negative, and it's not really the proper term for it. I guess you can call it the negative bus. Maybe we can call it that. So these are going to be just kind of tacked in there. I imagine. Okay. Now this one will probably just sink right in. It's this one I'm going to have to spring load it a bit. There, that should do it. Let's see what happens. That wire's on there, but just barely. It's not. I gotta put a little bit of, whoops, a little bit of rosin on that. Just a little wee bit. I don't know. Let's just see. Yeah, it's good. Next one will be the actual power wire here. Let's untangle a couple things here. To myself, where did this wire come from? I don't remember a solid. Yeah, right, this is from the other radio. That's what this is. Come on. Tidbit of wire there. Well, I'll leave it in there. If it wants to stay that bad, who am I to say no? Okay, put that through the hole. Okay, that's the power cord. Power connection made. Now we'll start at the lowest terminal down there, which has coming to it. Let's see, these two are on the upper. This capacitor is going down to the bottom. I think that's the only thing that connects down there. Okay. I think I can get it to go. There we go. Okay, now the middle one has this capacitor I put in there. I just need a little bit of... This is actually a shrink sleeve that's on here. That's good. And this capacitor goes to the center terminal. That's where the audio is coming out, heading for the audio amplifier. So ungrounded volume control is what the problem was in this radio. And that will eliminate the ability to reduce the volume mostly, because you now turn the volume control into a potentiometer. You turned it into a variable resistor. Now this green wire, I got hung up on those capacitors here. My chance to free it out of there. And this is the wire that carries audio from a record player or something else. Let's put it in through here, such as an iPod into this phono plug back here. This is also carrying the full volume signal out of the radio portion of the radio here, the radio receiver portion. Oh, I was going to change this because this is a little high, so we'll change it. I can pull it off there. It's quite the terminal. I don't think so. So I'm going to cut it and leave a little leg behind. That's 22. That's 2.2 megohms, I believe. Let's see if we can quickly find that one. So that's coming off the top of the volume control. R7. R7. Oh, 4700. It's not that one. So how about R, whatever that is, R3 it looks like. I don't know what that is, R3. 2.2 megohms, there we are. R3, 2.2 meg. Okay, 22. 22 megohms is a red, green. So all I gotta do is look for, what's that doing in there? That shouldn't be in there. There's another one. What are these two guys doing in here? Get out. Get you out. 22. The green. This one. Ah, must be an easier one to get, isn't there? Red, green. Look at that. That's a nice one. That's a pretty tiny, but it's the same tiny as that one. So here we are. Let's check them. Let us not be fooled. New doesn't mean better. I stand by that. .3 instead of 2.2. You know, that's fine. that is fine. So we'll put this guy on there like that. Whoa! That stupid thing there. I had my finger on the resistor wire. That didn't go well. That's only one of the wires anyway. I gotta get this guy on there. I need every last little millimeter of them. There we go. Get in there. Come on, is there enough room in the hole? See if we can knock the rest of it off now. There we are. I'm through. No, I'm not. There, I am through. Right there. Twist the terminal there, Jim. Whew. Pretty close to the limit of how many times you can fiddle with that terminal. There. Okay, that's soldered up pretty good, I'm pretty sure. Okay, the last connection is this resistor back to this terminal here. Just about ready to try this radio out and have a miraculous result. Could I put the volume control in backwards? Could I have done that? Over here, Jim. Yep, it's possible to put a control in backwards, but I doubt very much that happened here. I think that's physically impossible. Okay, we are ready to start it up again. Let's just double check. It's connected. It's good. Nothing came off. Switch off. Okay. I'm going to flip it over so we can. See it for what it really looks like. What's it look like? Looks to me like it wants to work. That's what I think it looks like. Let's just move a few things around here. Tool clean up. I try to not let my bench get too cluttered up while I'm working. Especially when I'm about to turn something on. I don't want too much stuff on my bench. You know, I don't want to add fuel to the conflagration that's going to come when I power this up. Talking about conflagrations, it's a huge one in Paris. Isn't that a sad thing? It's a sad thing. Okay. But let's be happy now. So I put the knob on even though it's a little loose. There we are. Yeah, I can see this knob is set in just a touch further than this one. Oh, this guy's not pushed in all the way. Thumbs up on that. Okay, plug in. Switch is off. Power on the dim bulbs. Power on. Perfect. Volume up a little bit. Not to be afraid now. I'm leaving my microphone volumes full up. Cover your ears. It's coming. Oh, son of a gun. Okay. Something not right there. Well, I guess I gotta figure out what stupid thing I did there. I put those wires back on by memory. That's a pretty stupid thing right there. So, almost certainly I booted that up. Sometimes you get away with stuff, sometimes you don't. Okay, so I'm going to review all this circuitry here and just see what kind of dumb thing I did. And we'll fix it, and this thing's going to work. I'm sure it's going to work. Okay, while I was looking into this, I suddenly remembered, hey, wait a minute, here's the old control. There's this piece of wire which loops around from this terminal down to the bottom of the volume control. Really? So this was positioned like that. It's coming off of here. That's better. Sure. So I just extend, I just left this out. This one, just a little piece of wire over there. That's all that's missing. Great. So I just get a little piece of wire and I'll fix that up. Let's see if we can do it with this. Pretty tarnished. The copper oxide is conductive. That's what makes copper so wonderful to use. If it wasn't conductive, then we'd have the aluminum wiring situation. Because aluminum oxide is not conductive. Canada went really big into aluminum power cables early on, because Canada has a lot of bauxite in Quebec. You make a lot of aluminum, you have a lot of electricity, hydro-powered electricity in Quebec, a lot. And so bauxite, electricity, bingo, you're making aluminum. Well, that's right. Somebody put tariffs on that. Right. Somebody who had agreed to not put tariffs on, put tariffs on. Now, who would do that? What kind of a country would make an agreement with another country and then just break it? Just break it, just like that. That would be a country you can't trust to make deals with. That'd be a terrible deal-making country. Okay, let's get back to the radio here. Say, is my sarcasm coming across? Shame on me. Take a little more of the insulation off here. Sometimes you can have corrosion on the surface of metal. That the corrosion product is so thin and so adherent. It might only be 3 or 4 atoms thick. Now you can still make contact with the electron cloud in the metal. So you can take these actually badly corroded pieces of metal, touch them together, they conduct beautifully. Stainless steel is an example of that. Stainless steel is badly corroded on the surface, but you can't see it. And it doesn't grow. It develops a very thin, I can't think if there's a proper term for it, but you can think of it like a coating, if you like, of I don't know what it is. Stainless steel has what other metal in it? Chrome. So maybe it's a chromium. Who knows? It's some complex metal. Metal corrosion salt kind of thing. But unlike other metals, it's just a couple of atoms thick and it stops. It stops itself. And that's why stainless steel doesn't corrode to death. You know, this isn't going to fit under that wire there. Let me try it again. So if you take a piece of stainless steel and you know, sand off this invisible coating, it will remake itself very, very quickly. And you know, the metal, just like this, has the metallic sheen. The metallic sheen. See, it's missing from this metal because this metal has a corrosion product on the cover, on the surface of it. Oh, I did this wire wrong again. How did I do that? Get in behind there. So this coating is thick, and I don't think it's conductive. probably if we just touch it with an ohm meter, we'll find out it doesn't conduct. But if you scratch it just a touch, you can get in contact with the electron cloud that's inside the metal, and conduction will start again. You know, I could have put this wire on while I had the control out of the radio. Yeah. A lot of hindsight goes on when you do this work, by the way. Some of your comments on videos that I read are simply the same hindsight I have after the fact. And if you notice, my personality is to keep pushing forward, regardless of what it is I might be looking at. I mean, you know, like this. I could have stopped, ordered one of these over the internet, wait a week or two, and carry on with the proper part. That's not my nature. My nature is to keep pressing on. Press on, press on. You notice a couple videos ago I got an awful lot of thumbs down. I got 9 on it very rapidly. This is a video where I put this in. So that's the worst. That's the worst I've ever gotten on a video. Really, comments are okay. One person said I did a terrible job here. Again, that's kind of a reflection of me just pressing forward here. You know, I'm not going to stop and order something, and I'm not going to do that. I'm going to get it done. It depends too. This is not a customer's radio. This is my own radio. This radio's got lots of other problems in the cabinets. It's not a beauty. This is not a beauty. I better get this on here because I'm running out of stuff to talk about. I start talking about politics. I can't let that happen. Come on, little wire. Come on. You're just fighting with me. Right there. Pop on now. Okay, you want to go there? No, can't go there. There it goes. That's just what I wanted. Right there. Perfect. Perfecto. Okay. Did I mention I'm continuing doing vast amounts of tube testing? At some point I'm going to be putting out a video that's going to show multiple tube testers and many tubes, same tube or sets of the same tube for comparative purposes, and we are going to find out what the truth is about tube testers, tube testing, and tubes, and probably me. The truth about me too. So, and in the meantime, what I'm doing is, you know, there's a method to my madness. I'm preparing myself to tube test my entire tube collection. That's a many-year project probably, because I just can't spend every night doing it. But I don't want to undertake that without improving my expertise in tubes and tube testing. And that's what this is all about. When you see me doing all this stuff, you might have seen videos where I'm using this thing to test tubes. Look, there's a tube in there now. it's really about me preparing myself to invest a lot of time testing on a lot of tubes and wanting to know for sure what I'm up to. That's down here. Wanting to know, are these tests valid? And the answer is basically, I'll give you the answer. My my dynamic tube testers are all reliable. The emissions tester I have, I should throw it out. So the emissions tester may be out of adjustment, and that's maybe why it's doing what it's doing, but it cannot differentiate bad tubes very well at all. Oh, one loose. Touch that. Okay, one loose, one I missed earlier. Here. I wouldn't want to test 1,000 tubes and then realize that the test is bogus or something like that. This wire, this green wire here. And on the tube testing, and generally speaking, you know, I have random boxes of tubes. I bought from people, yard sales, various ways, boxes of just tubes, and sorted through them and all that kind of stuff. I ended up with quite a few very good radio tubes. So, for instance, a good tube would be a 12 SK7. I've got 20 of them. Of the 20, 3 of them are completely dead. 5 of them test really pretty darn low. Half of what's left tests okay, and the last half, which is now like a quarter or something like that, tests really good. That's how it's kind of come out. Oh, I've just given away the whole thing. Not really. Okay, we're ready to try it again. I am ready. I don't know about you, but I am ready. I am ready. I don't think we're going to get a big blasting hum out of it this time. Switch is off. Plug is in. Power's already on. I should come down for a better view of this. And you better back up a bit just in case. Sparks and flame come out. We're on the dim bulbs. Presto. Okay, put the volume up a little bit. And be ready on the switch. Power switch. I'm ready. Oh, listen to that. Check it out. It goes quiet. It goes loud. And now we'll tune something in. Hear it? There's a voice there. I think like when you have it set to 600 here, it's really like 550 or something. So 590 would be up. Go around here. Well, manhandling that tuning capacitor back there, but no, it doesn't want to pick up a station. Great though, I can even turn it off. Fantastic. Okay, so this is fine. This is really good. So we're ready to approach the alignment. We'll run through it again. The IF should be fine. It shouldn't have been thrown off by any of this. I think what we're experiencing here is really bad front end tuning. The result of that is the signal on the antenna is not resonating in the radio anywhere. It's not being lifted out of the noise, so to speak. And the radio's just awash with noise. That's what I think is going on. So a little more tuning, and I think this guy will be done. Thanks so much for watching the volume control saga, and I'll see you on the next video.